It's working. Ha! Da da da! Run! Rolling and going.
What are we learning about today?
This is 5, 3. I think there's decimals for y'all, aren't there?
I don't know.
Whatever.
Do it, Barrett.
We're going to introduce probability trees.
Probability tree?
Yep.
Oh, and should we get the grocery tree? Intro what?
Introduce.
Introduce probability trees.
BB.
I got like 15 minutes.
That's good.
Let's do it. All right.
It's not super bright.
Okay, so
Deep bright.
so my goal today will be to do a quick basic introduction to probability trees and then a fast example. So you have a little bit of time to process, and then we're going to come back and we're going to look at details tomorrow. We're going to look at like all the nuances of it.
Okay.
Sound good?
Yeah.
Okay. So you guess so? Guess so. Okay. So here we're just going to draw an example of a probability tree.
Oh man, I did not miss those.
If
Oh no.
hopefully you saw this in
In what?
Algebra 2.
And I did not like it. I did not like
Sure, it is.
I think I cheated. Is it like a sport?
it. I think I cheated.
Honestly, though, same.
If
I swear I did not like it.
so,
Kira, you repeat yourself one more time.
but I'm going to reteach it all, so it's totally cool. If you
Don't speak of her.
don't remember,
Or never learned it.
Say, or you don't want to remember. Or you just
Refuse
walk
to
it out of
learn.
your mind.
Hannah, you
So-
remember this? Okay.
so everyone walks a path. There's your philosophical statement for the day. Everyone walks a path, whether you choose to or not.
Sun Tzu.
I know, isn't it? So some people choose A, and some people do not choose A. But even in choosing A, you're choosing to not go down this path, right? And if you choose to not go down this path, you will go down this path.
Okay.
Everyone travels a path. And the same works with B. Okay. The sample space, so these events right here, we'll do these events. So the events here are going to be A and B, A and not B, not A and B, and not A and, whoops, not B.
Okay.
Okay, and really, for those of you that really loved Venn diagrams, or you loved two-way tables, yeah, that. If those are things that like you just totally got, I'm going to try to connect these. You're going to need to do a little bit of tree work, but if things just work better for you in the Venn diagram or in the two-way table, if you want to back up to the last unit, once you have everything figured out, it's fine by me. So we can say like this is event A, this is event B. It's going to get a little sketchy when we have like 3 choices, 3 paths you can travel. So, but usually it's only 2 choices. So I'm trying to give you a little bit of grounding on that. So this right here would be A and not B, right? This would be B, whoops.
Not a.
Yeah, and not A, but usually we'd flip-flop it. I messed up. On the outside, we have A didn't happen and B didn't happen. and we have A and B. So,
There you go.
yeah, it's pretty neat that you can put all that in a Venn diagram if you want. Or you could do a table.
It's freaking cool. Well, yeah, 'cause I wanted to make it pretty.
So you can make a two-way table based on this. You can have your totals of your A, your totals of your not A. Right?
Oh, what were those called?
Two-way
Squares?
two-way tables.
Yeah. Wow.
Two-way tables. That's what we're calling them. It's A and not B. This is not A. Not B, and this is noops. Not A. Not B. And so it's actually interesting that that you can display the same information in 3 different ways, and students will say like, I just get Venn diagrams, but I don't get the two-way tables, and I go, like, I don't really understand, right? Like it's the same thing.
Did you get
Like I know that like you might like a visualization better, but like the thinking process of like this is a total and whatever, it's the same thought. It's just a different way to look at it. Make sense?
Yep.
But there we go. There's all 3 of those. And so if you want to know like what's the probability from a tree, like what's the probability of B happening, you're going to have to do the not, or the A and B, and the not A and B. Right? So for the tree, so we'll put a little dash here. And call it like the other ways. Right? So then the tree, you're going to have to find like the probability of B. If you wanted to know what that is, well, it would just be the probability of A and B plus the probability of not A and B. Because these are now mutually exclusive, right? Everybody travels one of the paths. Okay, let's talk numbers. Yes, ma'am?
Yes.
This is the plus sign right here. Because this is the probability that B happens, right? So we don't actually care about A. So A could happen, or it could not happen. Doesn't actually matter to me. And we could do stuff. Do you want to talk about givens real quick?
Sure.
Can I just address that? Yeah, so we could say like, what's the probability of A given B? And so from here, I would say, oh, well, that's just going to be the probability of both A and B happening divided by the probability of B happening. Yes, ma'am. I will explain that. So here, could you give me that we used before? The little folded up paper we had in Roundup. So here we have the Venn diagram from Roundup that we used. So. Okay, so like the probability of D given B, right? So these were the disease birds and blue birds, and so we have a Venn diagram. D is disease, B's blue. So probability that you're a disease bird, given that you're blue, is 25 over 37, right? Are y'all with me so far? Okay. So, but if all of this added up to 100, right?
Right.
Then, and so we don't know what these outside numbers are, but if I told you that the probability of B was 0.37, right? Because this would be like, if this was 25 and 12, if I told you the probability of B was 0.37, yes? What's the probability of D given B? Well, it'd be 25 over 37, right? And then I could put decimals in front of both of these, so 0.25 and 0.37. Yes? So then the probability that it's a blue bird would be 0.37, right? And the probability it is diseased and blue would be 0.25, because that's 25 out of the 100 birds. That make sense? So if you got Venn diagrams, there's that. If you got the two-way tables better, where we did givens like probability you are red given math. Given math, it would be 20 out of 55, right? There's 20 and there's 55 total items. So given math is 20 out of 55. And so you would say 5. The probability you are red in math is 5 out of the 55 total folders. 5 out of 55 divided by 20 out of 55 is 5 out of 20. Which is cool. So, and we'll work with this more tomorrow. So if you're confused, we'll do real examples, and hopefully when we make some real examples, you'll get it. You guys doubt me right now, silly students. Okay, general rule of thumb. We're going to add the branches. For our ors. Like the branches of the tree. We're going to add our branches. So we're going to add these pieces. For the or of, let's put or of ands. So we are very clear. The only thing you're adding are these pieces right here. The only thing you add are these pieces. If you need to make a note to yourself on your notes, it's fine. The only thing you add are these pieces right here. Those numbers all over this tree. The only thing you're going to add are these pieces. Okay. And to find the ands, multiply as you go. Does that make sense yet? It doesn't make sense yet. It will. Just wait. Just wait. Multiply as you go. It's like a whistle while you work type thing, right? Oh no, I got 1 minute. So let's say the probability of A happening is 0.6. So the probability of A not happening is 0.4, right? Yeah. If you choose the path of A, probability that B happens is 0.1, and the probability B does not happen is 0.9. So to get to find the and, you multiply as you go. 0.6 times 0.1 is 0.06. If you choose the A path and then you go down this way, this is 0.54.
Right.
Maybe this is 0.8 and this is 0.2. To get the and, you multiply as you go. 0.4 times 0.8, 0.32. Right?
That makes sense.
0.4 times 0.2, 0.08. And we'll look at this more tomorrow, but there is your introduction with some numbers. Whew!
You know, Barrett, I get it.